Imagine there's an invisible shield around Earth that protects us from deadly space radiation and solar winds. But what if it disappeared? Could we survive without Earth's magnetic field? Our planet's magnetic field is like an invisible force field. It helps animals find their way and keeps our technology safe. But most importantly, it keeps us alive. Today, we're going to explore what would happen if Earth's magnetic field suddenly vanished. Join us as we dive into the mysteries of Earth's magnetic field and explore the consequences of living on a planet stripped of this invisible protector. Hit that subscribe button and click the bell icon so you never miss an exciting episode of Quantum Quest. The basics of Earth's magnetic field. So, what exactly is the magnetic field? It's created deep inside the Earth by the movement of hot, liquid metal. This movement makes electric currents, which produce magnetic fields. These fields form the magnetosphere, a huge bubble that stretches far into space. The role of the magnetosphere. The magnetosphere is our planet's shield. It deflects harmful particles from the sun, called solar wind. Without it, these particles would strip away our atmosphere and blast the surface with dangerous radiation. The magnetic field also protects our satellites, keeping our GPS and communications running smoothly. Immediate effects of losing the magnetic field. Scientist: if the magnetic field vanished, the effects would be immediate and severe. Solar wind would hit the atmosphere directly, causing it to degrade quickly. We'd lose important layers like the ozone, which protects us from UV radiation. With a weaker atmosphere, more radiation would reach the ground, increasing risks of skin cancer and other health problems. This radiation would also damage the DNA of living organisms, leading to mutations and possibly wiping out entire ecosystems. Long-term environmental impact. Over time, the loss of the magnetosphere would be devastating. Earth's surface would be bombarded with solar radiation and cosmic rays. This would likely heat up the surface, making it hard for life to survive. The atmosphere would continue to erode, leading to a significant loss of water. Without water, plants would struggle to survive, and the entire food chain could collapse. Earth could end up as barren as Mars. Impact on technology and infrastructure. It's not just living things that would be affected. Our technology would be at risk too. Satellites, which rely on the magnetic field for protection, could malfunction or be destroyed, disrupting GPS systems and international communications. Engineer: our power grids are also vulnerable. Solar storms, usually deflected by the magnetosphere, would hit Earth directly. This could cause massive power outages, damaging electrical grids and causing chaos. Human adaptation and survival. So, could we survive? It would be a huge challenge. Humans are adaptable, and we might find ways to protect ourselves. We could develop advanced shielding technology, or even create underground habitats to escape the radiation. However, these solutions would be expensive and take a long time to implement. We'd need to find new ways to grow food without traditional farming, like using hydroponics or lab-grown alternatives. Medicine and genetic research would also be key to helping us adapt to higher radiation levels. Historical perspective and lessons from Mars. Looking at Mars can give us some clues. Mars once had a magnetic field, but lost it billions of years ago. Without this protective shield, its atmosphere was stripped away, leaving the planet dry and barren. This shows what could happen to Earth if we lost our magnetic field. The science behind the magnetic field. Geophysicist: the Earth's core, composed mainly of iron and nickel, is divided into a solid inner core and a liquid outer core. The motion of the liquid iron in the outer core generates electrical currents. According to the dynamo theory, these currents create the magnetic field. The Coriolis effect, due to Earth's rotation, causes the spiraling movement of the molten metal, contributing to the field's stability. This process is self-sustaining as long as the core remains active. However, changes in the core's dynamics, such as cooling or alterations in the flow pattern, could potentially weaken or even stop the magnetic field. The history of Earth's magnetic field. Earth's magnetic field has not always been stable. It has experienced numerous reversals, where the magnetic north and south poles switch places. These reversals, known as geomagnetic reversals, occur over thousands to millions of years. The last major reversal happened about 780,000 years ago, known as the Brunhes-Matuyama reversal. During these reversals, the magnetic field weakens, but it does not completely disappear. However, the transition period could make the Earth more vulnerable to cosmic and solar radiation, which might have had significant impacts on the planet's climate and biological evolution. Magnetic field in modern times. In recent decades, scientists have observed that the magnetic field is weakening at a rate of about 5% per century. This has led to speculations about an impending magnetic reversal. The South Atlantic anomaly, a region where the magnetic field is particularly weak, has been the subject of intense study. This anomaly affects satellites and increases the risk of radiation exposure for astronauts. Space scientist. Understanding these anomalies is crucial for preparing future space missions and protecting our technology. Continuous monitoring of the magnetic field is essential for predicting and mitigating potential disruptions. Global cooperation and research. Protecting our magnetic field and preparing for any potential changes requires global cooperation. Scientists around the world are working together, using satellites, ground-based observatories, and computer models to study the magnetic field. Projects like the European Space Agency's SWARM mission provide valuable data on the field's structure and dynamics. Public awareness and support for scientific research are crucial. By understanding the magnetic field's importance, we can better appreciate the need for environmental conservation and scientific funding. Final thoughts and speculations. Imagining a world without a magnetic field is a stark reminder of how interconnected and fragile our planet's systems are. From the deep currents of the Earth's core to the far reaches of the magnetosphere, every component plays a vital role in sustaining life. While the complete loss of the magnetic field is highly unlikely, the possibility of significant changes underscores the importance of scientific vigilance and preparedness. As we continue to explore and understand our planet, we must also strive to protect it for future generations. Thanks for joining us on this journey. Stay curious, stay informed, and keep exploring the wonders of our universe. Credits and acknowledgements. We'd like to thank all the scientists and researchers who contributed to our understanding of Earth's magnetic field. Special thanks to our viewers for supporting educational content. Conclusion. In conclusion, the magnetic field is crucial for maintaining life and our way of life on Earth. Its loss would bring about catastrophic changes, affecting everything from our health to our technology. While we might find ways to adapt, the best course of action is to protect and preserve our planet's natural defenses. So, next time you see a compass needle pointing north, remember the invisible force that makes it possible. And let's continue to support scientific research that helps us understand and protect our planet. Through understanding, innovation, and resilience, we can face whatever challenges come our way. Until next time, keep exploring the mysteries of the universe with Quantum Quest. If you enjoyed this journey into the unknown, don't forget to like, subscribe, and hit the bell icon to stay updated on all our latest videos. Share your thoughts and questions in the comments below. We love hearing from our curious community. Thanks for watching.